Hey Algebra 1, here are your notes for 12.2 with rational expressions. So chapter 12 digs into the artistry of algebra. Bet you didn't know that algebra could be artsy. But it challenges you to combine several simplification techniques in order to make really complicated things easier. So before we jump into that, first question, what is a rational number? A rational number is anything that falls into one of these categories. It can be an integer, it can be a fraction, or it can be a decimal. And spell that one right. Okay, integer, fraction, or a decimal. Next, if we know what rational numbers are, it makes sense that a rational expression is a combination of those. So a combination of rational numbers. I may have to change pen colors. Yep, you're gonna change pen colors quick. All right, let's go to blue. So because a rational expression involves division, the denominator cannot equal 0. Remember, when we divide by 0, the universe implodes on itself, bad things happen, and a black hole is probably created somewhere. But any value of the denominator that results in division by 0 is called an excluded value. That's a really good word to know and to write down. So excluded value is something that we are going to care about. All right, let's keep going then. Just grab another pen in case this one runs out. So how do you find excluded values? Well, to find excluded values, we're going to set denominator equal to 0. And why do we do that? Well, we know that the denominator can't be 0. So if we set it equal to 0, that tells us which values aren't going to work for us. So let's look at the examples here. To state the excluded value of this expression. Well, if I take the denominator and I set it equal to 0, I say m plus 2 equals 0. This tells me that the denominator is going to be 0 when m equals negative 2. So m cannot be negative 2 because it creates a problem for us. All right, let's jump over to the next one. If I take the denominator and set it equal to 0, I get x squared minus 9 equals 0. I move the 9 over. X squared equals positive 9. And as I talked about in one of my last videos, when we take the square root of anything, you should remember that you get the positive and the negative version of whatever that square root is. So after I've square rooted both sides, I get both positive and negative 3. Now what this tells me is that while the last one only had one excluded value, this one has 2. And I need to be aware of both of them. All right, I want you to pause the video here. I want you to try 2, 14, and 13. Yes, I'm aware that those are funny numbers, but I want you to try those on your own and then come on back and we will try them together to see if we get the same excluded values. All right, hopefully you took a minute to pause the video and try these on your own. We're going to quick find those excluded values together. So, set the denominator equal to 0. A cannot equal negative 32. And I should actually fix these up here as well, because if we're stating the excluded values, what that means is that they cannot be equal to whatever it is that we find. Same with this one. 3y squared minus 12 equals 0. Move the 12 over. We get 3y squared equals positive 12. Divide both sides by 3, and I get y squared equals 4. Remember, when I take that square root, I'm left with positive 2 and negative 2. And because they're excluded values, we cannot include them. All right, last one here. Let me just zoom in quick here. There we go. This one's a little tougher, but it's going to be the same method. We're still going to take that bottom denominator. We're still going to set it equal to 0. Now the difference here is that we're going to need to factor in order to figure out what those ends are. So this one, no number out in front, no need for the X puzzle. So I can drop it down. What multiplies to negative 5 and adds to positive 4? Well, the only factors of 5 are 1 and 5. So those are going to have to be my factors. Then how do I make the 4 positive? I have to make the bigger number positive, the smaller number negative. Of course, this is where I use my zero product property. This has to be set equal to 0, and this has to be set equal to 0 in order to find that my excluded values are 1 and -5. For those of you that like to circle your answers as I do, there they are. Not too hard finding excluded values, right? All we're doing is solving the same way we have been and then putting a not equal to sign. All right, let's jump to the back page. So the process for finding excluded values and simplifying. The big thing you need to know here is that you always find excluded values first. And then simplify. Then simplify. We have to do this because if we don't, we may miss out on some of those values. All right, let's jump down here then. We start by setting the denominator equal to 0 and finding those excluded values. Now, what could I put into y or z in order to make this 0? Well, since we're multiplying, if y equals 0, the bottom equals 0, and if z equals 0, then the bottom equals 0. So my excluded values for y are 0, my excluded values for z are 0, and now that I know that, I can simplify this expression. 54 divided by 24, those are both divisible by 2, so I'm actually going to bring this over here. I'm going to divide a 2 out of the top, leaving me with 27. I'm going to divide a 2 out of the bottom, leaving me with 12. I still have z to the third on top. I still have yz on bottom. I notice these are both still divisible by 3, which tells me I didn't factor out the greatest common factor. So I also need to factor a 3 out of both of them. That leaves me with 9 on the top and 4 on the bottom. Now I have simplified the fractional part, which just leaves me with the variables. z3 on top with a z on bottom. When I subtract their exponents, I'm left with z squared on top, and the y doesn't simplify. Since I can't take this and simplify it any further, this is my final answer. All right, I want you to try this example on your own. I know it looks tricky, but I do want you to try this. Pause the video here, give it a shot. All right, hopefully you paused the video. Welcome back, we're gonna do this one together. So, start by checking those excluded values. X squared minus 5x plus 6 equals 0. When I factor this, no number in front of x means no need for the x puzzle. Put in my x's. The only things that multiply to 6 are 1 and 6 and 2 and 3. And the only way it looks like to get a positive number here, but a negative number in the middle, is to make both of them negative, because 2 negatives multiply to a positive. And then, since I'm subtracting, it's going to be 2 and 3. I use my zero product property to check both sides, and I find that my excluded values are positive 2 and positive 3. And all I did was solve this to figure out what two values to plug in. The nice thing is that by factoring it, we've actually solved ourselves a step in the process of simplifying. So when I simplify this, I've already simplified the bottom. I made it x minus 2 and x minus 3. Well, why does that help us? Because that leaves only the top to be broken down. Notice it's a binomial, so the only way we could possibly break this one down is by factoring out a GCF. Notice they both have a 3 in common. When I factor that out to the front, or undistribute it, I'm left with an x in the first and a 3 in the second. Now, remember, the same way that I took a 2 as a GCF out of this and a 3 as a GCF out of my second fraction, notice that these technically have an x minus 3 divided by an x minus 3. When we divide anything by itself, because there's multiplication in the middle of these, dividing anything by itself results in a 1. So this is technically just a fancy 1, and we can cancel it. We can make it into just a 1. Once we've canceled those, we are left with 3 over x minus 2. And because there's nothing else we can simplify there, because there is a subtraction in the middle, this is our final answer. Of course, with our excluded values being 2 and 3. But, quick check. Remember, this problem said that we had to simplify and state the excluded values. While we did that, I want you to notice that 2 is technically one of our excluded values, and if we plug it in, it doesn't work. That is why it is excluded, because it does not work in the final problem. 3 does, but it would not work for the original, so it does not work, period, at all. So just a little check there. All right, again, I want you to pause the video, give these 3 a try, and then come on back when you've given those an opportunity for learning. All right, hopefully you paused the video and gave these a shot. First, state those excluded values. I've got a squared b squared equals 0. What could I plug in for a and b that would cause this to be 0? Well, a can't be 0, and b can't be 0, so those are my excluded values. Now, let's simplify. I can't simplify that 12, so I'm going to leave it on top. But I've got 1a on top and I've got 2 on bottom. When I subtract their exponents, I'm left with a single a on the bottom. I've got a b on top and b squared on bottom. When I simplify, I'm left with b on bottom. I cannot simplify anymore, so that's my final answer, including my excluded values. Number 6 here, check the denominator. X squared minus 1 equals 0, move the 1 over. This means that x cannot be, when I take the square root of both sides, it cannot be positive 1 and it cannot be negative 1. All right, simplify it down. The top is going to factor into xx plus 1 plus 1. The bottom is a difference of squares because the first thing is squared and the second thing is squared. So we unsquare the first, put it in the first 2 blanks. We unsquare the second, put it in the second 2. Because it's a difference, we make the signs different. From here, we're simplifying. Remember what I did in that last problem up here. If I have the same thing on top and bottom separated by multiplication, all I have to do is turn them into a big 1 because it reduces to 1. I'm left with x plus 1, x minus 1. Be careful. If they're not the exact same, we cannot simplify like this. Because x plus 1 and x minus 1 are different signs, we cannot simplify them anymore. This is the number 1 error that I see when people simplify their rational expressions, and it kills me. So please be careful when you are simplifying. We can reduce things that are the same. We cannot reduce things that are different. Reduce the same. Don't touch anything different. All right, last one here. Looks super crazy. I promise it's not. Check the denominator. A squared plus 5a plus 6 equals 0. Factor that down to a Everything's going to be positive here, so we've got a positive 2, positive 3. You'll notice I'm not going through the factoring every time because that, my friends, was chapters 9 and 10. So I'm not going to keep going back into that. If you're still having problems with factoring, though, please let me know. I would love to give you some extra resources for practice. All right, finish up with that ZPP, zero product property. When I solve, I notice that A becomes -2 and -3. But those are my excluded values, so they don't work. Circle that because that's part of my answer. And then for the sake of space, I'm going to bring this all the way down here. Don't you love all my arrows? They're so fun. All right, I'm going to factor that top piece into AA. The only factors of 2 are 1 and 2. The only way to get them to add to positive 3 is to make them both positive. And then we already factored the bottom. It's A plus 2 times A plus 3. Now this one looks a little tricky because I didn't put the A plus 2's right over each other. But again, because they're separated by multiplication and they're the exact same term in the parentheses, I'm going to turn these into a giant 1 because they reduce. They don't cancel, they reduce. There's technically a giant fancy 1 in there, and we are just taking it out of the problem so that we don't have to look at it. I'm left then with A plus 1 divided by A plus 3, and I can't simplify because they are different. Remember, if they're different, don't touch. And then we just say, these are excluded values for a simplified problem. I know this is a little hard to see. I'm going to make some dash marks so you can simplify this problem. But there it is. There's your introduction to rational expressions. Practice makes permanent, people, so please practice, practice, practice. And let me know if you have any questions at all. I'd be happy to help.